anytime you start a lesson with solving, the basic idea of solving is that you're going to be doing math to both sides of a problem. That's what it means to solve. You do math to both sides legally in order to get the variable alone. All right, so that's the whole point. We're going to do math to both sides to get x alone. That's the whole point of solving. Anytime you start something with solve, that's what that means. So there's a couple things we need to talk about with logs and how to cancel logs out. So if we have a log base b, that b could be any number. It could be a 10, a 3, a e, a 5, a 17. It could be anything. That base could be anything. There's a couple ways that you can cancel that log out. One of them you already know. If you have a big B that matches the little b, those things cancel the log out. Okay, and it's gone. There's another way to cancel a log out, and if you have the log base of b, there could also be that same b letter, could be down here as a power. We call that like a super base, and that would also cancel the log out. All right, so those are two ways that you could cancel the log out. The first way would already be in the problem. It's already given to you. The second way is something you would do to cancel a log out. All right, so let me show you how that's going to work. All right, if you want to solve a log problem, so let's say we have a log that has a base of 3. Whoops, that doesn't look like a 3. There we go. Log base of 3 of the quantity x plus 4, and that's set equal to 2. And our job is to solve, which means we need to do legal math on both sides to get x by itself. So we start to ask ourselves, well, what do I want to get rid of? And the first thing you want to get rid of is the log. And a legal way to get rid of a log that has a little base 3 on it is to introduce a base 3 onto the log side. But if you do it on one side, you have to do it on the other. That means on the log side, the 3 and the log cancel each other out. All you're left with, bless you, is x, bless you again, x plus 4. On the other side, the 3 relates to the 2 like 3 squared. It becomes, the 3 is bigger than the square, the 2, like larger in size, so the 2 becomes a power. And so that's 3 squared, which becomes 9. And then that's a super easy problem to solve. X is 5, you're done. So it's just learning how to do legal math to both sides, like with that yellow number 3. So we're just going to practice that for, I got 9 of these to practice, because each time we're going to learn something different. We'll see if we get through all of them. We've got one down. All right, so let's try another one. So let's solve, okay, the log base of 5, parentheses 2x minus 1 equals 2. All right, there's our question. So we want to do legal math to both sides, and we want to make sure we do the right thing in the right order. All right, so Daisy, what do you think we should do first? To both sides. She's thinking about it. Yes, very good. We want to add 1 to both sides. Okay, we don't want to get rid of the log yet. We need to add 1 first. So that would be our first thing, is that we add 1 to both sides. That's our first legal move. That leaves me with the log base of 5 parentheses 2x equals 3. The next thing we want to get rid of on both sides is the log part. Okay, so Ryan, how do I get rid of that log? A base 5, right? Okay, so we're going to do base 5. And so I'll do a base 5 on both sides. What happens on the log side is that base 5 cancels out the log, and we're left with 2x. And on the right side, we get 5 cubed, which is a math fact I hope you know, and that's 125. Okay, 5 cubed. And then you divide by 2, And so the answer would be the fraction 125 divided by 2. Try not to give me decimals, please. Just give me fractions. Okay, so each time we do one, we're going to see something different. So it won't be exactly a cookie cutter problem like the one before, but it'll be something similar. All right, so for our next one, let's solve 4 plus the natural log this time of half x equals 3. 4 plus the natural log of half x equals 3. All right, Jarvis, get us started on that one. What should we do to both sides? Okay, subtract 4 first. That is going to give me the natural log of 1/2 x equals -1. Now we want to get rid of a different kind of logarithm. This is a natural logarithm. So last time we used, or the last 2 times, we used a base 3 to get rid of the log base 3. We used a base 5 to get rid of the log base 5. Now we have a natural logarithm. All right, any suggestions on what base I should use on both sides? Base e, right. Base e is the only thing that cancels out the natural log, so I'm going to use base e on both sides. So e cancels out natural log. That leaves me with 1/2 x. E to the negative first on the other side. Remember that negatives in this land mean fractions, and e to the negative first is 1 over e. That's what e to the negative first means. And so then our last thing, we just want to focus on getting x by itself. Okay, so Pedro, what can I do to both sides now to get x alone? What do I want to get rid of? How do I get rid of half? Multiply it by what? Okay, multiply by the reciprocal. So I'm going to multiply 1/2 by 2 over 1, and I'll do that on both sides. And so that will leave me with x being by itself, and I get 2 over e as my answer. Please don't put that into a decimal, just leave it as a fraction. So here we saw a new thing, which was e, and we also saw, not necessarily new, but a refresher on what to do with negative exponents. That negative exponents are fractions. Okay, let's try another one. So this time we're going to solve the log of x squared, and that's going to be equal to 4. Okay, Sam, as you're copying that, what would you think about, what would you want to get rid of first, if this were up to you?
Log.
How would you get rid of this log? So we've seen getting rid of a log with a 3 base. We've seen getting rid of it with a 5 base. We've seen getting rid of it with an e base. How do we get rid of this log? A 10. Right, very good. Okay, we're looking at base 10. And so this will be a base 10 on both sides. That will cancel out the logs. That's going to leave me with x squared equals, and then 10 to the 4th has 4 zeros. Okay, Sarah, what will do to both sides next? And we're trying to get x by itself. And what goes in front of every single square root? Remember? A plus or minus, yeah. When we do a square root, we are going to, on both sides, we have to remember the rules from before are still that we're going to have a plus or minus in front of every square root. And the square root of 10,000 is 100. And so the answer to this is plus or minus 100. So what new thing did we see here? We saw base 10, and we saw a refresher on square roots. So I know it's a lot of notes, but every single one I'm trying to show you something new and remind you of something that you learned before. Okay, this problem. The log base of 4 of parentheses 3x plus 2 equals another log base of 4 of 6 minus x. Now this time I've got logs on both sides. So I got to get rid of both of them. All right, Natalie, how can we get started? How can we work on getting rid of this log? Okay, I'm going to use a base 4, and we use it on both sides. And as luck would have it, that's going to cancel out on both of them. And that's going to just leave me with 3x plus 2 equal to 6 minus x. And so in this case, both of the logs canceled out. You're only allowed to use one base on each side, okay? Just want to throw that out there. You can't use multiple bases on a side. It has to be one base, the same base on both sides. Okay, now we're going to add x to both sides to keep working towards solving that. So that'll give me 4x plus 2 equals 6. Then I'll subtract 2 from both sides, giving me 4x equals 4, so x must be equal to 1. So here was a situation where we had 2 logs. That was the first time we'd seen that. We hadn't seen 2 logs together before. All right, well, now that you've done 2 logs, let me show you what to do with 3 logs. All right, so suppose we have 3 different logs. We have the log of the quantity negative 2x plus 13 minus the log of the quantity 6 equals the log of the quantity 4x. All right. When solving for logs, you need to simplify to where there's no more than 1 log on each side. No more. You can have less than 1 log on a side, but you can't have more than a log on one side. And so here I've got a situation, I've got 1 log on the left, but I've got 1 log on the right and 2 logs on the left. And you have to consolidate those logs. You have to combine them. And so we learned the property yesterday about how to combine a subtraction log, right? What does a logarithm turn a subtraction into? Division. And so we are going to simplify this with our parentheses, and we're going to get negative 2x plus 13 divided by 6. So you have to get down to the point where there is no more than 1 log on each side. Less is fine, but no more than 1 log. Okay, so Connor, now I'm ready to get rid of the log. How am I going to do that? So there's something I could do that would get rid of the log for me. You can't divide by a log. Yeah, that's not how you're going to get rid of a log. Okay, Ben has an idea. Is that all right? Yeah. Okay. Say that again. Okay, base 10. Okay, we want to use base 10. Yes. Okay, because the implied log is that it's base 10. And so we're going to use a base 10 on both sides. That will cancel out the log on both sides of the problem, giving me negative 2x plus 13 over 6 equals 4x. And I think it'd be a good idea under your 4x if you did 4x over 1. Because when you put 4x over 1, that allows you to cross multiply. And so our next step would be to cross multiply. That's going to give me negative 2x plus 13 equals 24x. And then I can solve that like I would a regular problem back from our Algebra 1 days, where we'd add 2x to both sides, giving me 13 equals 26x. And then where I divide 26 on both sides and reduce, and x would give me 1/2. Okay, so just a reminder, you can't have more than 1 log on a side at a time. So here's another one where you're going to have more than 1 log that you have to simplify first. Okay, so let's say that you have 2 ln x on one side. On the other side, you have ln 3x minus 2 plus ln x minus 1. So I have a couple properties that I am looking at here. One is the property of addition, and one is the property of a coefficient. We learned two properties yesterday that's going to help me. Let's start with the coefficient part. That 2, where did it come from? Say that again. It came from the x. So your first job is to use the property to put that 2 back. And so we'll move that 2 back into its correct spot, because we can't have any coefficients when we're solving logarithm problems. So this would be the logarithm then of x squared. So we put the 2 back. Okay, remember, no coefficients in a logarithm problem. On the other side, I've got the addition. And addition in logarithms converts to multiplication. So I'm going to put a big set of parentheses around a smaller set of parentheses that has 3x minus 2 and x minus 1. Okay, a big set of parentheses around the smaller set of parentheses. Once I've used those two properties, the addition property and the coefficient property, that's the power, then I can get rid of the logs. Okay, so Lauren, can you give us the right base to use on both sides that will help us work towards getting rid of our logs? Okay, E is the correct one. So we'll be using E on both sides. E cancels out, leaving me with x squared equals parentheses 3x minus 2 and x minus 1. And now I got to remember how to finish solving this. What do we do on the side where there's the double set of parentheses? What's legal to do there? FOIL. Okay, FOIL is the legal move to do next. So I have x squared equals, I'll get 3x squared minus 3x minus 2x plus 2. I need to group the like terms together. So 3x squared minus 5x plus 2. And then I need to set it equal to 0. Any squared problem has to be set equal to 0 before you can solve for x. So I'll subtract x squared so that I can have this be equal to 0. So 0 equals 2x squared minus 5x plus 2. Okay, who remembers what to do next? How do you solve a problem that's set equal to 0? Ben? Oh, I could use the quadratic formula. Sure, that will always work on a squared problem. I could do star factoring also. So at this point you have your choice. You could either do star factoring or the quadratic formula, whichever you're more comfortable with. My preference is usually star. 4 and negative 5 would work for negative 4 and negative 1. That doesn't mean negative 1 and negative 4 are my answers. That means that I take the negative 4 and I write it and I follow it with the negative 1. Okay, so some of you are slipping into some bad habits of star and you think, oh, negative 4, negative 1, those are my answers. They're not. They're part of the process so that you can group factor, split factor, leaving you 2x, x minus 2, leaving me with negative 1, x minus 2, so leaving me with 0 being equal to x minus 2 as the common factor, and 2x minus 1 as what's left. Then each of those gets set equal to 0. And then we're in the home stretch because x is equal to 2 and x is equal to 1/2, and we end up with 2 answers that solve this original problem. Okay, I said 9. I think we're just going to do one more. We won't do all of them. I think one more would be good. Okay, so why did I show you that one? Well, I wanted to show you to remind you what to do with a plus and a coefficient. I wanted to remind you what to do with FOIL. And I wanted to remind you about how star factors work. Okay, last one. the log of x minus 3 minus half of the log of x equals the log of 2. Okay, so a couple things here. I have a subtraction, but I also have a coefficient. I can't have either of those. I've got to take care of both of them. So I should take care of the coefficient first. And so I'm going to move the coefficient back. That'll be the first thing. So I still have my minus. I haven't taken care of that. And I've got a fraction, which I'm doing backwards here. I'm putting it back into its original form, which means I don't go with this fraction, but I'm going backwards. The fraction goes back into a radical. And so this fraction is going to go back into a radical, and this is going to be the radical of x. Okay, the fraction goes back into a radical if you're doing the property the opposite way. Then I do my subtraction, which turns into a division problem. So one big set of parentheses, and x minus 3 over rad x. And then I just have the log of 2 on the other side. Once I'm to the point where I have a single log on each side, then I can use the right base. And the correct base would be base 10. Leaving me with x minus 3 over rad x equals 2. And I think 2 would be better if it was written 2 over 1. Always better when it's written over a single fraction, so that you can cross multiply. So I'll have x minus 3 equals 2 rad x. I need to get rid of my radical before I can get rid of anything else. And so I need to square both sides. Now this is a little dangerous because people get sloppy here. Squaring both sides means putting parentheses and squaring it, and putting parentheses and squaring it. So be careful that when you square, you actually do what it means to square, because what it means to square is to multiply something by itself. And on the other side, it also means to multiply something by itself. On one side you FOIL, on one side you don't. You FOIL on the side that has subtraction. You don't FOIL on the other side because there's no subtraction. So this side would just become 4 regular x. 2 times 2 is 4. Rad x times rad x is regular x. On the FOIL side, we have x squared minus 3x minus 3x plus 9. Then I want to set that equal to 0. Let's see, let's group the like terms together first. And then I'm going to minus 4x to both sides. That will give me x squared minus 10x plus 9. Which is another opportunity for me to either star or do the quadratic formula, whichever is your preference for solving that. I always try star first to see if I can get it to work. And it did. Oh.